Hey, what's up?
Hey man, nothing much. Just scrolling through Instagram. Here, look at this.
Seriously? You find that funny?
Man, that's hilarious. What are you talking about?
Whatever. So, I was just taking a shower, and I was just thinking, have you ever, actually thought about how your vision works? Have you, actually sat down and, how do you see,
I don't know what you're talking about, man, because, look, I go over, I look forward, and I see it. It's just there. That's how you see. You just see it, man.
What?
Yeah.
No. I'm talking like the neural pathways and stuff. How it's like you see the light and then it goes into your brain and then the parietal lobe. Like that?
I really haven't thought that far ahead. I'm not gonna lie. I didn't even think that was a thing. I thought it just somehow formed in my brain. I don't know how though.
Okay, picture this. I see you sitting there on a chair, but that's not what my eye sees. The only thing that my eye happens to see is just light.
So what you're saying is you can't see me right here? Because man, I'm right here in front of you.
Hold on, let me explain. Of course I see you. But that's not what my eye happens to see. The first thing that happens is that light travels to my eye. Think of it as an airplane, traveling from my eye all the way to your eye.
Where are we?
We are in your eye. Let's zoom out so you have a better understanding. Currently, we're in the aqueous humor, right before we get to the lens.
Ah, okay. I'm still a little confused. Where are my arms? I'm just a ball of light. What's going on?
It's okay. This is only temporary. This will help us learn the visual system. But instead of just talking about it, we are going to go through as if we were actually lights. So right now, we are just lights. Isn't that great?
I'm still a little worried about it, but I'll come along for the ride.
So like I mentioned earlier, we are in the aqueous humor right before we get to the lens.
Ah, the lens that bends the light so we can see it right.
Yes, but no. The lens is only important for fine adjustments. Most of the work is done by the cornea, which is behind us.
Ah, okay. That makes sense.
The current aqueous humor that we're in helps give structure to the eye and allows light to pass through. Now let's go to the lens and go to the vitreous body.
Why am I still upside down? How did I even know I was upside down?
Ah, good. You're getting used to your new body as a light flare. We are currently upside down because of the lens properties. The lens was flexed by ligament muscles that flipped us upside down in order to be processed by the retina.
That's crazy to think about it, that we are inside an eye. You're right here, but also right there. Crazy.
Yeah, don't think too hard about it, but let's continue. For the sake of clarity, we'll be reverted back to normal so we won't get confused. But don't forget, from this point on, everything is reversed and will be flipped.
Ah, sounds good.
Okay, that is better. Alright, like I said before, we're in the vitreous body. It is a space like the aqueous humor, but in the middle of the eye. This semi-viscous area gives shape to the eye, and if you look around the eye, you will see the first layer of the retina.
Is it that red line going through the eye?
More like around the eye, but yes. The retina has 10 different layers, each have their own purpose and solution. If you look at the center and a little bit down, you will see something called the fovea. This is where all the clearest possible vision is. Everything from this point starts getting blurry beyond the fovea. The fovea is where all the light is mainly angled towards. This is where images are most in focus.
Okay, that sounds good. But what about right there where all the veins are going?
Yes, that's a good point. That is the blind spot. We don't see it in our normal vision because our mind makes adjustments and stitches the two images together as if there was no space there.
So you're telling me the mind is creating a portion of my vision?
Yes, but only a very small portion. We have spent a long time in the vitreous body. Let's actually start making a move. Let's go to the retina. Now that we made it to the retina, let's get a closer view of what we are actually looking at. Now that we are at the front/end of the retina, it's important to distinguish that light travels in one direction where the signal travels in the opposite direction. Since we are light, we will first follow the path of the light signal.
This sounds kind of complicated. but...
It's okay. Everything will work out. Just follow me. Since we are going to be following the pathway of light, the first thing we do is actually go through all the layers, then get absorbed by the pigment epithelium.
So we're going to that red squishy thing?
Yep, we are going to be converted to a neural signal.
How are we going to pass through all the layers?
That is because the cells in the retina are transparent, allowing light to pass through them.
Wow, that's crazy.
Now that we are the pigment epithelium, we now can go to the opposite direction of the light is going.
Okay, so what is the next step? Is it the rods and cones?
Yes, the rods and cones are next, and depending on what part of the retina the light is being directed on, determines whether you go through a rod or a cone. If light is directed closer to the fovea, you are most likely to go through a cone. But if you're further away from the fovea, and you are in the peripheral vision, you will go through a rod.
So, what are the rods and cones?
So the rods are for sensitivity, and cones are for acuity and color accuracy. Since you reflect just slightly closer to the fovea, you will go down a cone, and I will go down a rod since I'm slightly further away from the fovea.
Okay, but don't leave me alone. I don't know how to get out of here.
It's okay, we'll meet up again at the ganglion cells, but you will be able to still talk. Cool. Now after the photoreceptor cells, we will go to the bipolar cell.
I'm stuck. I can't get past.
Ah, that's right. Your photoreceptor cell is being inhibited by the horizontal cells. These horizontal cells control the rate at which signals are passed. And if there is a cell that is stimulated, the neighboring cells are inhibited and not allowed to fire.
I'm stuck here forever? I don't want to be here. I want to go back to being me, not just a light signal.
No, stop being a crybaby. You will go, just have to wait your turn. I'll wait for you in the bipolar cell.
Okay, it finally opened up for me. I can come through now.
See, I told you, nothing to worry about. Now we're going to the bipolar cell. This cell sends the signal, aka us, to the ganglion cell. I think you're going first.
What are you talking about? I went right through the bipolar cell. I'm at the ganglion cell.
Yep, that's because the Ackerman cell stopped me from going any further. I'll join you in just a second. Okay, there we go. It opened up. Perfect. We have reached the ganglion cells. And now can finally go to the optic nerve. That will send us to the optic disc, and eventually to the optic chiasm.
Yep, I'm ready to go. Oh, cool. You finally joined me. Thank you for coming. Good to see you.
Yep, you are ready to go to the optic nerve and get out of the retina.
Yes, let's go.
Now that we have made it all the way through the retina, we can now travel from the optic nerve to the optic disc.
We are at an intersection, and I don't know where to go.
Yes, we have reached the optic chiasm. At this point, where we go is determined by what part of the eye we came from. If you remember, when we first started our journey, we entered the eye on the upper left side of the left eye. This means we take the pathway of the superior left hemisphere route in the left eye. Since we are on the outer side of the eye, we will travel along the red pathway.
Why don't we cross over like the other lights are?
If we were on the right superior side of the left eye, we would cross over. But since we are on the left side of the left eye, we do not cross over. The same is for the right eye, but flipped.
Ah, I see now.
Nice pun there. Anyway, time to move to the lateral nucleate body. Here, we will be transferred to either the temporal or the occipital lobe. We have reached the lateral nucleate body.
That's cool, but why don't we just go straight to the parietal lobe and the occipital cortex?
Well, this would be great to have a straight track. That's not how it works. The signal at this point splits into a lower and upper. This splits the image vertically.
So from the original light image that we first came from, it is flipped and then reversed?
Yep, it's weird, but that's just how the visual system works. The upper pathway goes to the parietal lobe and the lower goes to the occipital lobe.
So where do we go?
Well, this is where we're going to split again. I'm going the upper pathway to the parietal lobe, where you will be going to the occipital lobe and the lower pathway.
So once I reach the occipital lobe, it's over? That's the pathway?
Yes and no. The vision doesn't stop there, but the visual pathway does. Okay, so that's what I meant by thinking about how we actually see, you know?
That was insane. I don't know how we were inside my eye and what.
Well, yeah, it was kind of crazy, but I gotta go do some homework right now, so I'll catch you later.